Let's do a quick Chinese remainder theorem problem. Not the best handwriting, but so let's set it up. And there are three congruences that we're going to try to combine to find one value for x that meets these three requirements. Just going to write out the numbers 2, 3, and 7. And then it's mod 3, 5, and 11. I'm going to use a method that is found in Rosen, which I like to use, and it's not the preferred method, I guess. It's not really the canonical method, but I like to use it. So 3, 5, and 17 are relatively prime, which is good. That means we can use all these equations, but I think this method can be used when these three numbers, or any number, are not relatively prime, but in this case they are. So what is 17 times 15? It is 35 and 50, which is really, is that right? No. But why did I do 17? No, I'm sorry, it is not 17. I have multiple problems that I'm looking at, and I made a mistake here. Sorry about that. This is really 11. There we go, 11. I was like, no, that's not what I'm doing here. Anyways, 3, 5, and 11 are relatively prime. And 3 times 5 times 11 is 15 times 11, which happens to be 165. So our answer for x will be some number mod 165. Okay, so the way to do this in Rosen's method is we take 2 mod 3 and we turn it into 3 t plus 2. And then we put it into the next one. Okay, and so it goes into 3 mod 5. Now, what I like to do for these problems is to just highlight this number, because I know that when or this part of the relationship, because once I solve for t, I want to be able to put it back in the correct formula, which is this one, and not 3t minus 1 is congruent to 0 mod 5. So if we try 1, we're going to get 3 minus 1 equals 2. That's not the case. Doesn't work. If we try 2, we're going to get 6 minus 1, which indeed is congruent to 0 mod 5. So t is congruent to 2 mod 5. We once again turn this into another variable, which can be 5u plus 2, and then plug it in here. Okay, so now 3 times 5u plus 2 is equal to 15u plus 8, right? 3 times 2 plus 2. All right, so then 15u plus 8 is now equal to the next one in the sequence, that being 7 mod 11. And that completes the task, so all we need to do is solve here. 7 mod 11. And as before, so I do not get confused, I'm going to highlight this equation because this is the one that I'm going to substitute into. So 15u plus 1 congruent to 0 mod 11. Right? And so, what are we going to do? Let's try, if we try u equals 1, we get 16. That does not work. If we try 2, we get 31. That does not work either. It's not a multiple of 11. If we get 3, we get 46. If we get 4, we get 61. If we get 5, we get 76. If we do 7, we get 106. If we get 8, we get 15 times 8 is equal to 120, right? And then we add 1 to it, and that is 121, which happens to be equal to 11 squared. So there we go. So the solution for u is 8 mod 11. We turn this into yet another variable. Let's call it v. So v is equal to, I'm sorry, not v, is equal to anything. We plug in 11v plus 8, right? 11v plus 8. This becomes 11v plus 8. Then we're going to plug it in to 15u plus 8. 15u plus 8. And I think we are done because this is 165, right? 15 times 11 is 165. Plus 8 times 15 is 120. And 8. So our solution is x is congruent to 128 mod 165. Now let's try it. Let's try in all the solutions. So 128, we're going to try 128 and we're going to try the next one. 128 2 mod 3. And let's also try 313, right? Is it? No, it's not 313. Making mistakes. It's 293, right? 581. Yeah, 293. So we're going to try both of those and see how we do. 126 divided by 3. Yep, works. 291 divided by 3 works. Okay, let's check the next number. 128 congruent to 3 mod 5. And then 293, which is the next number up, 3 mod 5. 125, 290. 5 divides them. We're done. Final check is 7 mod 11. Well, that's easy for that one. And then 293 mod 11. So this is 286 divided by 11. 2, 6. So sure enough, I think we have the correct answer. And it is right here. 128 mod 165.